This is section 1.8. We're going to start with absolute value equations. So just a reminder about absolute value. Absolute value tells us to take whatever is inside the absolute value brackets and make it positive. It's essentially, the definition is the distance from 0 on the number line. So for instance, if I took the absolute value of -5 is 5 units away from 0 on the number line. Same thing with +5, the distance is 5 units away. And because we're dealing with a distance, it always has to be positive. So what we're going to do is we're going to solve some absolute value equations, and then we're going to graph them as well. And this one's pretty straightforward. If the absolute value of x is 3, then I know that I could put a 3 inside of there to get 3, but I could also put a -3 inside of there to get 3. Now, that one's pretty easy and straightforward, but what happens when things are more complicated? So let's talk about a strategy. When I'm solving an absolute value equation, I'm going to take whatever is inside and I'm going to set it equal to the value that is there, and then I'm going to set it equal to the opposite sign, or the negative value of whatever is there. So here, that's all I had to do, and those are my two solutions. And if I graphed them, it would just be a dot at -3 and a dot at 3, and I'm all done. So obviously we're going to look at some that are more complicated in a second, but I want to point out something that's super duper important, which is the second example, which seems equally trivial, but it is not. Because this one says the absolute value of x is -3, which means they're saying I'm going to take something and take the absolute value of it, and it's going to give me -3. Well, I know if I plug in 3, the absolute value of 3 is 3. And if I plug in -3, the absolute value of -3 is 3, not -3. So is there any number whose absolute value is -3? No. So my answer is no solution. It's impossible to take the absolute value of something and get a negative number. So let's take a look at the kinds of questions we typically would get. Notice here on my first example, I've got an absolute value expression and it's all by itself, and that makes me happy. I want the absolute value all by itself. So all I'm going to do, once I get to that point, is set it equal to 3, and notice when I do that I can drop the absolute value brackets because I'm actually going to write it twice and set it once equal to 3 and once equal to -3. Now you might be saying, well, hold on, you just told me I couldn't do that with a negative. But remember, the absolute value can't equal a negative. The expression can when I write it twice. So now I'm just solving two very similar equations. I'm going to subtract 5 on each side, divide by 4 on each side, -2/4, which reduces to -1/2. On the right side, I'm going to subtract 5 from each side. I'm going to divide by 4 on each side. And now I get two solutions, and I could graph those as well. Oops, there's no -0. Don't be like me. Oh, and I've gone the wrong direction. That's all right. We're just going to go with it. -1/2 would be halfway between 0 and -1, and then -2. And that would be my graph of the solution. Now for the second one, notice how I got all excited. The first one already had the absolute value all by itself. The second one does not, so we have to do some work. So just think of this as a variable. The whole thing is a variable. Try to get that variable by itself. So I'm going to add 2 to each side first. That gives me 2 times x minus 8. And then if I add 2 to each side, I get 8. Don't distribute the 2. We don't want to do that. That's a bad idea. So just divide each side by 2, because we really just want the x minus 8 to be all by itself. And notice I have not taken it out of the absolute value sign, because the only time I can do that is when I write it as two equations. So now I have x minus 8 absolute value equals 4. And I'm okay with that because 4 is a positive number. So now I'm going to write it 2 times. X minus 8 equals 4, and x minus 8 equals -4. And then I solve by adding 8 and I solve by adding 8. And then again, I can graph my solutions, which are just dots on the numbers that I have. Okay, you're up. Try this one on your own. When you're all done, press play to check your work. Again, this one, x plus 3, is not all by itself, not quite yet. So the first thing I'm going to do is get rid of that negative 1/2. So I could divide by a negative 1/2, but we all know dividing by fractions is silly. So I'm going to multiply by negative 2 on each side. When I do that, negative 1/2 times negative 2 is positive 1. So on the right side, I just have x plus 3, still inside the absolute value. On the left, negative 6 times negative 2, I don't know where 7 came from, equals 12. And so now I have an absolute value all by itself equal to a positive number, so I'm okay. Now I'm going to write it as x plus 3 equals 12, and x plus 3 equals negative 12. Subtract 3 from each side to get 9, subtract 3 from each side to get negative 15. If I were to graph this, I would just put a dot on each of those values and be all done.